Okay, so the next thing that we have here is a couple of exercises that basically that we have related to these ellipses. There is 10 to not much really, not many exercises. Okay, so the first exercise that we have here is find the coordinates of the foci. Basically you want to find F1 and F2, the vertices, the length of the major axis, the minor axis, eccentricity, and the latus rectum of the ellipse. Latus rectum of this ellipse over here, which is x squared by 25 plus y squared by 9 is equal to 1. Okay, so the first thing that you notice about this ellipse is that, as you can see, the coefficient of x squared is 1 by 25. The coefficient of y squared is 1 by 9. And as you can see, the coefficient of the x squared has the larger denominator compared to the coefficient of the y squared. That means that the major axis of this ellipse is along the x-axis. So then the things that the information that I can find is basically the major axis along the x-axis. So that is one thing that I know about this ellipse. And also when we derived the equation of the ellipse, we said that it was x squared by a squared plus y squared by b squared is equal to 1. Now you can see that your a squared is equal to 25 and your y and your b squared is equal to 9. That means that a is equal to 5 and b is equal to 9. A is equal to 5 and b is equal to 9. So now that I have this information about my ellipse, and of course I know that the center is at the origin. Now I can draw a diagram of this ellipse over here. Sorry, b is equal to 3 here. B is equal to 3 here because b squared is equal to 9. So that means that your a is equal to 5. So this is the center and 1, and if that is the center, then you have 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5, and 1, 2 and 3, and 1, 2 and 3. So So then your ellipse is going to be, if you connect these points, it's going to give you, it is going to give you your ellipse. This is your ellipse. Now, what you want to find is basically the coordinates of the foci. Now, the coordinates of the foci are well, the coordinates of the foci are the foci, we said that if you have this ellipse over here, well, of course, if the major axis is along the x-axis, then this distance is going to be a. This distance over here is going to be b. And if this is, for example, let's say f1 and f2, then this distance over here is going to be c. That means that your foci are at a distance c from the center on both sides, meaning that the coordinates of this focus is basically c comma 0, and this over here is negative c comma 0. So, and there is, since you have your a and b, you can calculate your c, meaning that the relationship between a, b, and c was a squared is equal to b squared plus c squared. That means that c squared is equal to a squared minus b squared, or that means that c is equal to the square root of a squared minus b squared. So your c is equal to the square root of a squared, 25 minus b squared is equal to 9, and that is 25 minus 10 is equal to 15, so that is square root of 16, which is equal to 4. So your c is equal to 4. Your c is equal to 4. So 1, 2, 3, and 4. This point over here is called f2, for example. 1, 2, 3, and 4. This is f1. This is negative 4 comma 0. This is 4 comma 0. So your foci are at these 2 points. Now the vertices are basically at the far end of your ellipse, meaning that this is vertex A and this is vertex B. So this vertex is at distance is at negative a comma 0. This vertex is at a comma 0, which is basically negative 5 comma 0 and 5 comma 0. So these are the vertices. Now the length of the major axis is of course 10 units, because this vertex is at the distance 5 from the center. This vertex is at the distance 5 from the center. 5 plus 5 is equal to 10 units. This is 10 units. Now these 2 points, if you go along the minor axis, this point over here, point C and point B, this point is at basically 0 comma A, and this point is at 0 comma negative a, and your a is equal to 5. I'm sorry, b. So this is supposed to be b, and this is supposed to be b. So this point is 0 comma 3 and 0 comma negative 3. And so the length of the minor axis is basically 6 units. Now the eccentricity, we said that the eccentricity of an ellipse is basically E is equal to C divided by A, which is equal to 4 divided by 5, which is equal to 4/5. And the Latus Rectum is basically the length of the Latus Rectum. We calculated that to be negative we calculated that to be 2b squared by a. 2b squared by a. So then the length of the Latus Rectum is going to be equal to 2 times b squared, which is equal to 2 times 9 divided by 5, which is equal to 18/5 units. So these are basically, so if I read along it says that since the denominator x squared by 25 is larger than the denominator x squared by 9, the major axis is along the x-axis. Comparing the given equation with this, we will get a is equal to 5, b is equal to 3, so c is equal to 4, which is correct. Therefore, the coordinates of the foci are 4, 0, -4, 0. The vertices are -5, 0, 5, 0. The length of the major axis is 10 units, and the length of the minor axis is 6 units. And the eccentricity is 4/5, and the Latus Rectum is 18/5. So that's basically all that we have learned about these ellipses. Okay, so you want to find the coordinates of the foci, meaning F1 and F2, the vertices, the lengths of the major and minor axes, and the eccentricity. And the eccentricity of the ellipse 9x squared plus 4y plus 4 times y squared is equal to 36. So now what you need to do is basically write this in the form x squared by y by a squared plus y squared by b squared is equal to 1. Since I want to get a 1 over here, I divide by 36, and then we will do something about these things over here. But so if you divide by 36 over here, you get 9x squared by 36 plus 4y squared by 36 is equal to 36 divided by 36. Now over here you have x squared by 4 times 9 by 36 is 1/4, so x squared by 4 plus y squared by 9 is equal to 1. X squared by 4 by basically plus y squared by 9 is equal to 1. Now, so what this means is that your a squared is equal to 4, and so a is equal to 2, and b squared is equal to 9, so b is equal to 3. And so what that means is that since the denominator of x squared is since the denominator of y squared is larger, that means that the major axis is along the y-axis. So then basically you can draw this ellipse. You can draw this ellipse. So over here I have basically 3 units over here, 1, 2, and 3. 1, 2, and 3. 1 and 2, 1 and 2. And I have my ellipse. I have my ellipse in this configuration along the y-axis. Now since I have basically a and b, I can calculate c, meaning that I can write basically a squared is equal to b squared plus c squared. So c squared is equal to a squared minus b squared. So c squared is equal to c squared is equal to basically 2 squared, which is equal to 4 minus 9. So if a squared is equal to b squared plus c squared, and if a is equal to 2 and b is equal to 3, so then I can write c squared is equal to a squared minus b squared. C squared is equal to a squared minus b squared. So then c squared is equal to basically 4 minus 9. So c squared is equal to negative 5. Oh, I have made a mistake here. You see, the calculation doesn't work here because because as the major axis is along the y-axis, then of course I have to write my equation not in this form. I have to write my equation not in this form, but in this form, basically x squared by b squared plus y squared by y squared by a squared is equal to 1. And that is because the major axis is along the y-axis. So then what that means is that now my equation over here was x squared by 4 plus y squared by 9 is equal to 1. Now if I compare excuse me, if I compare these equations over here, so then I have basically b squared is equal to 4 and a squared is equal to 9. So b is equal to 2 and a is equal to 3. And now I can calculate. So these are basically wrong. And this is also wrong. So now I can calculate my c. So I said that a squared is equal to b squared plus c squared, and c squared is equal to a squared minus b squared, which is equal to, so this is your a and b, so is equal to, basically a is equal to 3, so 3 squared is equal to 9 minus 4, which is equal to 5. So that means that c squared is equal to 5, so c is equal to the square root of 5. C is equal to square root of 5. So now this, basically this ellipse over here, with this ellipse over here, basically your major axis is along the y-axis, so here you have your basically your a, or 0 comma a. Here you have 0 comma negative a. Here you have b comma 0. Here you have negative b comma 0. And so basically this is 0 comma so these are all basically wrong. So these were wrong, and so basically 0 comma a is basically 0 comma 3, 0 comma negative 3, and b over here is 2, so that's 2 comma 0, negative 2 comma 0, and then your foci are at basically your foci are going to be at 0 comma c and 0 comma negative c and 0 comma negative c. So c is equal to square root of 5, so you are 0 comma square root of 5 and 0 comma negative square root of 5. Now square root of 5 is equal to square root of 5 is equal to is equal to somewhere around 2.2, 2.236, and so on and so forth. So 2.2 would be somewhere over here. Is, let's call this, for example, f1, and that is basically 0 comma square root of 5, and the other focus is at 0 comma negative square root of 5, which is somewhere over here. Let's call this f2, which is at 0 comma negative square root of 5. Negative square root of 5. And so now we have our foci, we have our vertices, we have the major and minor axes, the length of the major axis. Major axis is basically 6 units. 6 units. The length of the minor axis is 4 units, and the next thing that we need here is the eccentricity. The eccentricity is basically C divided by A, which is equal to square root of 5/3. Square root of 5/3. And that's basically all that. So square root of 5/3 is correct. A is equal to 3, B is equal to 2. And the foci are correct. The vertices are correct. The length of the major axis is 6 units. The length of the minor axis is 4 units. And the eccentricity is that. Okay, so the next question that we have, you want to find the equation of the ellipse. Find the equation of the ellipse whose vertices are at plus or minus 13, 0, and the foci are at plus or minus 5, 0. So if your vertices are at plus or minus 13, 0, that means that your vertices are along your basically major axis, and so this is the length of your A. It means that your A is equal to 13. And if your foci are at plus or minus 5, 0, 5 is the length of your C basically, because your focus is C units away from the origin. And also you see that your vertices are at these 2 points, and so So what that means is that your major axis is along the x-axis. Your major axis is along the x-axis. Because if you draw this over here, you will get, basically what you will get is basically 13, 0 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's 13, 0. And you have basically negative 13, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's negative 13, 0. And then your foci, these are your vertices. And then your foci are at plus or minus 5, 0. So 1, 2, 3, 4, 5. So that's 5, 0 and negative 5, 0. And so based on this, you can calculate your A. So basically, you know that A squared is equal to B squared plus C squared. I'm sorry, your B basically. So B squared is equal to A squared minus C squared. So B squared is equal to A squared 169 minus 25. 169 minus 25 is equal to 4. 144. B squared is equal to 144. So B is equal to 12. B is equal to 12. So it doesn't really make much sense. I mean, so then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12, basically 0, 12. 0, 12, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. That's 0, negative 12. And so your ellipse is going to be basically this thing over here. Your ellipse is going to be this thing over here. So that means that basically your B is equal to 12. Now what you need to, basically what you want to find out here, you want to find out the equation of this ellipse. So since the major axis is along the x-axis, I can write basically x squared over a squared plus y squared over b squared is equal to 1. So I know my a, I know my b, so I can write x squared over a squared 169 plus 169 plus y squared over b squared, which is equal to 144, is equal to 1. That is the equation of your ellipse. So the next question that we have here is find the equation of the ellipse. Find the equation of the ellipse whose length of the major axis is 20 and foci are at 0, plus or minus 5. Okay, so basically you know that since your foci are at 0, plus or minus 5, your foci are along the y-axis. So these foci are along the y-axis, meaning that and since the foci are on the major axis, then you can say that the major axis is along the y-axis. Now, so what that means is that basically your C is equal to 5. And the length of the major axis is 20. If the length of the major axis is 20, that means that your A is equal to 10. Because 10 would be, if the length of the major axis is, for example, suppose that the major axis is along the y-axis. So, for example, you would have something like this, and the length, if this length is basically 20 units, then this would be basically 10 units, and this would be 10 units. That means that your A is equal to 10. And so what that means is that your B is equal to, that means that you know that A squared is equal to B squared plus C squared. That means that your B, basically B squared is equal to A squared minus C squared. So B squared is equal to 100 minus 25, which is equal to 75. And B is equal to the square root of 75. Now the square root of 75, is 5 square root of 30, is equal to 5 square root of 30. So your B is equal to 5 times the square root of 30. 5 times square root of 30. So what that means is that now I know that the major axis is along the y-axis, so the equation of the ellipse becomes x squared by b squared plus y squared by a squared is equal to 1. So then I can write x squared by by 20. So b squared would be 25 times 3, which is equal to 75, plus y squared by a squared, which is equal to 100, is equal to 1. And that is the equation of your ellipse. So the next question that we have is, we want to find the equation of the ellipse. We want to find the equation of the ellipse. The major axis is along the x-axis. Your major axis is along the x-axis, and passing through the points the points 4, 3 and -1, 4. So this way you can find your A and B, and this way you know where to put them, because the equation of an ellipse is either x squared by a squared plus y squared by b squared is equal to 1, or it is x squared by b squared plus y squared by a squared is equal to 1, depending upon the fact that whether basically your major axis is along the x-axis or along the b-axis. You pick one of these equations, and moreover you need your A and B. So over here you can find your A and B, and then based on this you know where to put them, and so problem solved. So what that means is that basically since the major axis is along the x-axis, then I can write x squared by a squared plus y squared by b squared is equal to 1. And then since this ellipse passes through this point, for example 4, 3, then you can write 16 divided by a squared plus 9 divided by b squared is equal to 1. So this is one equation. Also the same ellipse passes through this point, -1, 4. So then you can write basically 1 over a squared plus 16 over b squared is equal to 1. This is equation number 2. And if you solve these two equations, you will get your A and B. So what you can do is that basically in equation number 1, I can write a squared b squared, and over here I can write 16 b squared plus 9a squared is equal to 1, and that means that So I can write this equation as so how do I solve this equation now? Okay, so I think I know what to do here. Maybe by substitution we can solve this problem, because this way there is no way to solve this problem. Meaning that I could write this as, for example, 16b squared plus 9a squared minus a squared b squared is equal to 0, and then now there is no way to solve this problem this way. So what I can do is that I can write 1 over a squared as x and 1 over b squared as, let's basically 1 over a squared be equal to x, and 1 over b squared be equal to y. Then equation number 1 becomes basically 16x plus 9y is equal to 1, equation number 3. And equation number 2 becomes basically x plus 16y is equal to 1, equation number 4. And now I can form a system of equations here. Basically I can multiply 4 by 16. I will get 16x, I write 3 as it is, 16x plus 9y is equal to 1, and 16x plus 16 times 16 is equal to 16 times 16 is equal to 36, 0 and 6, that's 6, 5, 256 plus 256y is equal to 16, and then negative, these two will cancel out, and of course this is 16x, these two will cancel out, and then you have 9y minus 256y, 256 minus 10 is equal to 246, 247y, 256 minus 9, 256 minus 9 is equal to 247, negative 247 is equal to negative 15. These two you can cancel out, so y is equal to 15 over 247. And I can use this now over here, for example. I can write 16x plus 9 times 15 over 247. 247 is equal to 1. Now let's see if that is divisible by 9. 6 plus 7 is equal to 13. No, not divisible by 9. What is 15 by 9? 135, 135. So 16x plus 135 by 247 is equal to 1. That means that 16x is equal to 1 minus 135 by 247, which is equal to 247 minus 135 by 247. Now what is 247 minus 135? That's 211. 112 by 247. So 16x is equal to that. So x is equal to basically 112 by 16 times 247. So if 16x is equal to this, then it means that x is equal to this divided by 112 by 247 divided by 16, which is equal to 112, 247. 247 times 1/16, which is equal to 112 by 16 times 247. And so you can simplify this a little bit. 112 is basically 50. So that's 56. 56. So over here you have 56 and you have 8. Divide by 2, you will get 25, 28, 4, 14, 2. Here we have a 7 and 0. And 247 divided by 7 is equal to not divisible. So 7 by 247. So your x is equal to 7 by 247. So now I can take the value of x and y. 7 by 247. X is equal to 7 by 247. Now over here we said that x is equal to 1 by a squared. X was equal to 1 by a squared and y was equal to 1 by b squared. So then I can write x squared. So then I can write x is equal to basically, so that what that means is that basically x, which is 7 by 247, is equal to 1 by a squared. That means that a squared times 7 is equal to 247. That means that a squared is equal to 247 by 7. And so a is equal to the square root of 247 by 7. Square root of 247 is equal to, so that is basically the value of your a, and then the value of your b is going to be, so over here y was equal to 15 by 247. 15 by 247 was equal to 1 by b squared. That means that b squared is equal to the reciprocal of this, which is 247 by 15. That means that b is equal to the square root of 247 by 15. That is the value of a and b. Now over here what we said was that the major axis was along the x-axis, and now I have the value of a and b, so I can write x squared by a squared plus y squared by b squared is equal to 1. So then I can write basically x squared by a squared, which is 247 by 7, plus y squared by b squared, which is equal to 247 by 15, is equal to 1. And that is the equation of your ellipse. The equation is right. I just need to know there is no solution here, which is okay. Alright, so this was basically the conclusion of all the theory that we had related to ellipses. Now in the next video we have a couple of exercises, 20 exercises related to ellipses, so I'll see you in the next video. Thank you.